Hey everybody, today we're going to continue topic 4 by looking at diagrams and combined probabilities. So our EQ for today, how can you rearrange the generalization rule to find the intersection between two events? Well, what we first want to think about is why do we care about probability diagrams? Well, they come in handy when we are trying to explain the results of a survey, experiment, or some other set of observations. Let's look at an example. What is the relationship between educational achievement and home ownership? We had a random sample of 500 people who participated in the 2000 census that were chosen for this random sample. Each member of the sample was identified as either a high school graduate or not, and as a homeowner or not. Overall, there were 340 that were homeowners, 310 that were high school grads, and 221 that were both homeowners and high school graduates in this survey. Now, the first diagram that can help us understand probability is something that's really easy once you learn how to read it, and that's called a two-way table. And when I say reading it, we have to understand the structure of what's going on in the table. Okay, so notice that we had two different events. That's our combination of events, and one of them was the graduation status. And we used the letter G to describe that graduation status. So they either answered yes or no. If they answered yes, they get a G. If they answered no, they got a G prime. Okay, then we also had the other event of being a homeowner. If they answered yes to that question, then they got an H. If they did not, they got an H prime. Remember, we use that prime to talk about the complement or the not this event. Okay, now let's go ahead and work backwards with this because that's going to be an easy way to start to understand how the table works and how we can read it. 221 were both homeowners and high school graduates. So what we want to try and think about is, all right, well, where's the intersection between somebody being a high school graduate and a homeowner? So my homeowners are represented here and my high school graduates are represented here. The intersection is this guy right here, and that is our 221 people. So let's go ahead and fill that in. 221. Next, we can see that there are 310 total high school graduates. So that means we are looking at this one right here. Well, intersection with what? With the total, right? It said overall there were 310 high school graduates, so the intersection for that is going to be right down here, okay? So intersection just refers to one cell, and it is where the rows and columns that correspond to what you're looking at combine. Next thing we want to look at is going to be the 340 that were homeowners, and so we should see that that's going to be the intersection between our total and our number of homeowners, and that's 340. The last number that we were given here is going to be our actual grand total. How many people in total were in this survey, and that's going to be the total cell, the very bottom right one, and that's 500. You think, well, wait, what about everything else? This can all actually be discovered by simple addition or subtraction, right? So let's go ahead and figure that out. We had 340 total people that were homeowners, right? 221 of them were high school graduates. So the difference between 340 and 221 must make up those that were the non-high school graduates. And that's going to be the number 119. Okay? 340 minus 221 gives us 119. That tells us how many were homeowners, but they did not graduate from high school. Next, we can see, all right, well, this one's going to be really simple. We had, for our homeowners, 340 of them out of 500. That must mean the remainder, or the difference between 500 and 340, which is 160, is going to tell us how many total non-homeowners we had. By the same token, we can look at that for the number of non-high school graduates. We had 310 out of 50 that graduated from high school. 500 minus 310 is going to give me 190, and that's going to tell me how many non-high school grads in total that I had. Working within the same column, if I had 119 of those non-high school grads that were homeowners, that must mean 190 minus 119 is going to tell me this cell right here, the number of non-homeowners that did not graduate from high school. Subtracting those two, we get 71. Okay, and then same token here, we can say 310 minus 221 is going to work with this column right here, and that's going to tell us how many graduated from high school but do not own a home. 310 minus 221 is going to give us 89. And there you have it. Two-way table is complete. Now we're going to be able to start to answer all kinds of interesting questions, so let's get to it. Calculate the probability that a randomly selected person in this survey is indeed a high school graduate. So if I want to look at those that are high school graduates, that's going to be looking at the probability that somebody is in that G group, right? So probability of G, we're going to use the same notation that we learned last time. So probability of G, we just want to see how many total people were in that group of G, and that was 310. But probability, we know that that's going to be a fraction, a number that is going to be less than 1. That's 310 out of 500, right? 310 out of 500, you can write that just as that fraction. You don't even have to reduce it if you don't want to. Probability is the one place where you do not have to reduce your fractions. You can also write it as a decimal, which I will do right now. But for the rest of it, you'll see that I'm just going to leave them in fractions. I like fractions. One more step to actually write as a decimal. Who cares? Okay. Next, probability somebody is a graduate and owns a home. So right now what we're doing is we're looking at probability that somebody is a graduate and they own a home. Okay. So if you were listening very carefully, I used the word and quite a bit when I was trying to fill in each one of these cells. Okay. The word and is going to tell us that what we want to do is find the intersection between those who satisfied both of those conditions, graduate and homeowner at the same time. And that's going to be this guy right here. That's the intersection between homeowners and high school grads. Okay? So that number is 221. And we can write that out of, again, our grand total 500. Every one of these simple combined probability problems are going to feature the grand total value as our denominator every single time. Okay? Next one, we are looking at probability that somebody is a graduate or owns a home. And that seems like it's the same question, but it's actually just slightly different with that word or. Or is much more inclusive. What or tells me is that as long as they own a home or as long as they graduated from high school, I'm going to count them. They are going to be included in this probability. So I like to go cell by cell here and just kind of do a check. These 221 people, did they satisfy that first condition of being graduate? You bet, so they're included. This 119 people, did they graduate from high school? No, they did not, but they do own a home, so they're included. These 89 people, they graduated from high school, so they satisfied that first condition. They are included. What about these 71? Are they going to be included? Well, they did not graduate from high school, and they did not own a home. Thus, they are not included. We do not count these folks, right? So it's just going to be all three of these groups. So what do we do with those? Do we write three separate probability values? No, we add them. So we have 221 plus 119 plus 89. And that's going to give me a total of 5 out of 500, right? Now, when we add up the numerator here, those three values are going to be 429 out of 500. And that is the probability that somebody is either a graduate or owns a home. So there's your combined events. Now, let's go ahead and use some notation because we don't actually like to use the words and or. Mathematics uses its own crazy notation, so let's use that crazy notation. Okay? Intersection. We write that as one event, A, is going to intersect with another event, B. So it uses this kind of weird cap. That cap looks like an upside down U or a lowercase n, but with no little serif, no little tail. Okay, and that's actually the way that I remember it. Is that intersection is referencing and to me that looks like an N, right? So to me, whenever I see that symbol, I see the letter N, and that makes me think of and. See how it looks like an N. Okay? Now, union. Union is a little bit more simple. We call it a cup, or you can also just call it the union symbol. It looks like a big uppercase U, but differentiates from the sample space U, the universal set, because it doesn't have the serifs here. So no serifs on any of these like Mr. Boucher taught you in the last lesson. All right, so here we will say A union B tells us the probability of A or B. Okay, so intersection is and, union is or. And the way that I remember that is that this looks like union because it looks like a U. So this is the outcome of a trial satisfies either A or B. Okay. Now, once we have these two things, then we can actually use both of these to come up with something that's called the general addition rule. General addition rule is not something that I use too often, but it's going to be on your formula sheet. You want to know what it is and when we can actually use it. Okay. So the general addition rule is pretty simple. It tells us how we can calculate the probability of A or B. It tells us how we can calculate the union. And that is by doing simply this. Probability of A plus the probability of B, but then we have to take away the intersection. And you might be thinking, why do we have to take something away if it's the general addition rule? Okay, well, let's go ahead and take a look up at our two-way table one more time. Looking at this two-way table, let's see which cells there were. Okay, we had these first three, 221, 119, and 89. I'm going to kind of use the general addition rule and use my highlighter to address that. So what we can say is, it's the probability of G or H. So it's everybody that satisfies G, right? So it's these guys right here that satisfy G. And then it's also anybody that satisfies H. So it's probability of G plus the probability of H. But then why do we have to subtract something? Well, what did we just do here? Did anybody notice the problem? What did I do with this number 221? I actually colored it in twice, right? So if we color it in twice, that means we're counting these 221 people 2 times, and that doesn't work. Mathematically, you can see what actually would be happening here if I use the general addition rule. That would be like saying 340 over 500 plus 310 over 500. What does that give me, right? If all you did was just add these two totals together and put it out of 500, that's going to give me 650 over 500. Well, then I have counted more people than I can possibly count because I only had 500 people. That should tell you that you counted somebody twice. So what we need to now do is subtract from it the intersection 220 out of 500. And now we can see 650 over 500 minus 221 out of 500, and that gives us our result that we originally found by doing it the other way, 429 out of 500. Okay, so the general addition rule will work anytime when you've got your two-way table all set up, but you can also do it intuitively by just reading the table, and that's always my recommendation to you. However, this general addition rule is going to be something that's really helpful whenever we get into looking at Venn diagrams and even algebra-based probability problems. So let's go ahead and get to that by flipping over the page. All right, so looking at this back page, we're now going to start talking about your good old friend Venn diagrams. So Venn diagrams can also represent probabilities of multiple events. You usually won't have more than 3 events. Maybe on occasion you might have a tough question that's going to involve 4, but for the most part, 3 is going to be tops. That's already enough. Okay, so let's go ahead and use the same example that we did. Let's create a Venn diagram using that same scenario. And we want to make sure that we label each circle and the sample space U. This is a huge requirement. Whenever you are asked to make your own Venn diagram, you have to make sure you include that sample space, which is the rectangle here. You have to draw that rectangle. If you don't include the rectangle, then you haven't included the universal set, and we can't say that you have adequately answered the question. Okay? So if we call this one H and we call this one G for my homeowners and my graduates, and then I have the intersection, and I remember that the intersection between those were both homeowners and high school graduates, that was 221, right? It's where the circles intersect, so that makes sense. That's our intersection. So how do I find out this value? Well, what I have to think about is the entire circle here, that was how many homeowners I had. Now that was 340 homeowners. Well, this part though is going to be the homeowners that did not graduate from high school. Okay, so 221 plus what gave me 340, and that was that one particular cell, 119. We can do the same thing by looking at this one. We have 310 total graduates. 221 of them were homeowners. That left 89 that were not homeowners, but they did graduate from high school. And then who's not inside of these circles? Who is neither a homeowner nor a graduate? That was our 71 individuals outside in the universal set. Okay? Now, let's use some notation. I've recreated a lot of these Venn diagrams because I like to do shading with whenever I'm looking at combined events and Venn diagrams. Shading in the areas helps me out a lot. So by recreating these, it'll help me shade in the areas that satisfy the conditions that I need. So this first one, H prime, right? So that is all of my non-homeowners. So this part here, those are my homeowners that did not graduate from high school. Well, they don't meet the condition that I want because I want to look at non-homeowners. Same thing with this intersection. That's not who I want, right? These graduates, however, that do not own a home, that's what I want. And I'm also missing one other group. That's my universal set. And this is why that universal set is so important, and that you make sure you include that rectangle so you don't forget about it. So really all I'm looking at is the 89 and the 71. What's the sum of those two values? That's 160. So we had 160 out of 500 that were non-homeowners. And you might think, well, couldn't we just use the two-way table for this? Yeah, but what if you don't have the two-way table? The two-way table doesn't gives you more information than Venn diagrams do, but Venn diagrams can be a little bit quicker sometimes. Okay, let's go ahead and look at part B. And I want to change part B. I don't want to look at P. I don't want to look at probabilities. What I want to do is remember some of the other notation. We're going to look at N. Remember that N is going to be the number that satisfy this condition, right? So how many individuals are not homeowners and also graduates? So again, I want to think about, well, who are my non-homeowners? I need to satisfy both of these conditions. I have my non-homeowners. Okay. These people are all non-homeowners, but they also have to satisfy that condition. We have to say, and they must be graduates. So now look at that second condition. Who are graduates? Let's choose a different color and color that in. My graduates are these. So now, what am I supposed to include? Everything that I've shaded in? No. What I want to include is just those sections that satisfy both conditions at the same time. Which ones are orange and which ones are black? And that is this guy right here. This is everything that I want. Just that number, okay? So just that number gives me 89 out of 500 for the probability, but again, I'm just looking for the number. How many of those individuals are there? And there are 89 of them, okay? Let's go ahead and take a look at C. C, I'm looking at H prime or G, okay? So now let's look at everybody that satisfies H prime. Who is not a homeowner? And we've got these guys right out here. And also these guys. That's all non-homeowners. Now let's look at graduates. My graduates are going to be these ones here. So now, because we are looking at or, we just have to satisfy at least one of these conditions. So basically now it's everything that you have shaded in, okay? So what's everything that I've shaded in? Adding all of these up might seem a little bit cumbersome, but take a look. There's only one piece that we did not shade in, and that was this part right here. So we can just look at what's the complement of that shape. What's the complement of the 119 out of 500? Just subtract from 500. And that's going to be 381 out of 500. That's everybody that's satisfied inside of here. You could also find that by just adding together the 221, the 89, and the 71, and that would be perfectly acceptable. Okay, so the next thing I would like you guys to try and do, actually, let's go ahead and take a look at part D. I want you guys to try and do E and F on your own. So let's go ahead and change again that to N. I'm also going to change F to looking at the number, okay? So now we have H and G prime, but here's what we want to pay attention to with the prime. It's now outside the parentheses. So if the prime is outside of your parentheses, what we want to start to do is let's look at order of operations. Shade in what's inside the parentheses first, H and G, okay? So that's this. But now, what does the prime tell us to do? The prime tells us to negate it. So actually, what you want to do is erase that and shade in everything else but that. Okay, that's what priming it means. That's what negating it means, is everything but, right? So everything there is very simply the 119, the 89, and the 71. You can add all of those values up, or you could look at it as the complement of the intersection. And that would be 500 minus 221, which gives us 379. And again, I'm looking at a number, so it's not a fraction there. It's just going to be that number, 379. Okay, let's take a look at one more example before we head out. Again, I want you guys to do E and F on your own, but let's try and figure out some word problems with some missing information. So you can even do super weird implicit algebra word problems using two-way tables or Venn diagrams, and IB loves these problems. I've seen them a lot on IB practice tests. So let's look at example 3. In a class of 26 students, it is found that 10 study Spanish, 16 study theater, and 4 study neither Spanish nor theater. So what we want to try and recognize is that the fact that we have two different classes here, and those can represent two different events really in our world, okay? And if we've got multiple events, that should tell you, hey, maybe we want to look at this in terms of like a Venn diagram, right? You don't have to use Venn diagrams, but this is a helpful tool to be able to answer those kinds of questions. So I'm going to draw my Venn diagram. I'm going to label them as Spanish, theater. I'm not going to forget that I've got a universal set here. And the only piece of extra information that helps me out is those that study neither Spanish nor theater, right? And that's this number down here, 4, because they don't belong in Spanish class, they don't belong in theater class, they're somewhere outside of that. Now, whenever we want to start thinking about these kind of questions, we usually want to try and fill in the intersection first, this piece. But do we know what that is? No, the only thing is that we know that 10 total people study Spanish, which is anything inside of circle S, and 16 study theater, which is going to be inside of circle T. So what that tells me is that, there's actually going to be some overlap here, and we need to figure out what that intersection is. That's exactly what part A is going to tell you, okay? So part A wants us to calculate the number of students who study both Spanish and theater. Okay, so let's go ahead and try and work with that. That's going to be looking at the number of students that studies both Spanish and theater. Okay, now I don't know what this number is. This is what I want to try and figure out. Okay, but I do have that thing called the general addition rule. And as I mentioned before, I don't tend to use it because I like to read my tables and my Venn diagrams intuitively, but this is kind of an algebra problem, and the general addition rule can actually really, really help us with the algebra. So let's look at this, and remember that my general addition rule is this. The number of Spanish or theater students, right, the union, is equal to the number in the first event that study Spanish, plus the number in the second event that study theater, minus the intersection between these two. Okay, now let's think about what we do know. I do know this, the number that study Spanish, I know what that is. I also know the number that study theater, I know what that is. The thing I don't know is this one here, this value. And it might seem like I don't know this value either, the number that studies Spanish or theater. We actually do. Just remember, there are 26 students in total. 4 of them study neither of these. So this one is actually really easy. That's just 26 minus 4, because that tells me if there are 4 that study neither, the difference, the 22, must study either Spanish or theater, and that's exactly what I want. Now, let's go ahead and start to figure this out. Number that study Spanish. Well, we know how many that is in total. That's 10. How many study theater? That's 16. How many study both Spanish and theater? That's our unknown value. That's the intersection over here. That's x. So now we subtract x. And look at how simple this turns out to be. 22 equals 26 minus x, okay? And once we have that, all we have to do is add x to both sides. X is going to turn out over here on the left-hand side, and it's now positive. The 22 needs to move over to the right-hand side. So when I subtract 22 from both sides, the 22 cancels out on the left. We're left with just the x, and then 26 minus 22 equals 4. And look at that, we found the intersection. We know how many students study both Spanish and theater just by using that general addition rule. So now let's start to think about this for just a second. Okay, if there are 4 people here that study both Spanish and theater, but 10 in total that study Spanish, how many must be in this part right here? Well, 4 plus what gives me 10? That must be 6. Okay, and then we look at the next one over here. What about theater? There's supposed to be 16 in total that study theater. 4 plus what gives me 16? That must be 12. And now, if you look at that, we have completed our Venn diagram. We should be able to answer the next question without any problem. So, hence find the probability that a student at random from this class studies exactly one of these subjects. I will leave that for you to answer. Okay, thank you guys. Make sure that you try to answer these last few questions because they will be on your warm-up for next time. Have a wonderful day.